Okay, cool. So here's part B.
Yep.
Here's part B. So what are we saying the probability of each one of these individual dies coming up a 5 is?
1/6.
Okay, and how about coming up any specific number?
1/6.
Okay, so we have 12 here, right? 2,
Yeah.
4, 6, 8, 10, 12. Okay, awesome. So does that mean when I roll all of these dice, I should see 2 of every single number? Because each number has a 1/6 chance of coming up. And I got 12 of them, so I should get 2 of each.
Well, you won't see that always.
Okay, why not?
Because there's also different cases.
Why don't you roll 4? I'll roll 4. Just keep talking while we shake up the dice. So, do you think we're going to see 2 of every number?
Oh, no, it's completely random what these come up as.
But even though it's a 1 in 6 chance?
Well, all choices are independent of each other. So,
Alright, so there's 9. Okay,
so we
let's
have
see.
2
2 6s. Some
But
5s.
we have
Oh, 3 6s.
3 choices. So we had 3.
we actually did get pretty close.
Okay, what did we get?
We got 3 6s, 2 5s, 2 4s, 3 3s, and 2 2s.
And no 1s.
Ah, no 1s. Interesting.
Because each choice these choices are all independent of each other.
Uh-huh.
So it's just as likely to have all like 5s as it is to have all 5s and a 2.
Not quite, actually. We're actually going to have some good probability questions today. All 5s would be, what's the probability? You don't have to tell me the exact number, but you can do the calculation. All 5s would be what?
Well, it would be 1 out of 6 to the 12th.
Yeah, 1/6 to the 12th. Now, 11 5s and a 2.
So that would be, because I think there would be 12 cases where this happens, because you can have any number of those 5s turn into a 2.
Right.
There's 11 cases.
So that involves something called choosing numbers. You have to choose which one of the die is going to be the 2, and you actually have 12 choices.
Yeah.
But there are the same number of cases if you said all 5s and this dice is a 2.
Yeah.
Then there would be the same number of cases. Actually, we have one, the white die, we only have one. So if you said all 5s and the white die is a 2. So yeah, so the interesting thing, going back to our original question, is even though the probability is 1/6, it doesn't mean you're going to get that every time. It doesn't mean if I roll 6 die, I'm going to get a 1, 2, 3, 4, 5, 6.
Yeah.
The numbers show up randomly, and what do you think it means then, sort of, if I roll lots of die? What do you think it means that the probability is 1/6? How would you describe that?
It's 1/6 that, like, if you have a specific number, it's 1/6 for each individual die.
Okay.
They're independent of each other, so this die rolls does not depend on what this die rolls.
Right.
So,
But what would you say about the chance of me getting, like, say, a 2? How many 2s would you expect me to get if I rolled, like, 120 dies?
120? So, I would expect you to get 20.
Okay. Would you expect me to get exactly 20?
No.
Just roughly 20.
Roughly 20.
About
Okay.
20.
All right.
I mean, that approximation will get better as you get, like, if you roll, let's say, 12,000 die.
Uh-huh.
I think it would be closer to 2,000.
Yeah. That's an interesting question. What does it mean to be closer? Like, is 15 closer to 20 compared to 1,900? Or, sorry, 1,980 compared to 2,000. So we have to, there's a lot of things to understand. It's a difficult subject. But what I really wanted to talk about today, and what we are going to go upstairs to the computer today and talk about, are prime numbers.
Prime.
Okay?
Okay.
Alright.